Hello everyone, welcome to this video. My name is Sambuddh Deep, a final year student of BTech Civil Engineering at Faculty of Engineering and Technology, University of Lucknow. Today, I am going to introduce you the topic named Cloud Seeding. These are the content which I will be covering are background, cloud seeding, the beginning, the Indian history of cloud seeding, how clouds are formed, type of cloud seeding, application, pros, cons, case study, conclusion, references. Before we can understand what a cloud seeding is, we must first understand why it is used or exists. We know water is the most important natural renewable resource on earth. It is under threat from ever increasing demand due to change in land use and growing population. It had been seen that water supplies decreases around the world, which result in deficient drinking water, agriculture, and so on. So, in order to increase water resource, many countries are conducting weather modification activities in region of the world. India, Indonesia, Malaysia, Thailand, and the UAE are some of the countries involved in weather modification activities. Now, what is cloud seeding? Cloud seeding is a weather modification technique that improves a cloud ability to produce rain or snow by introducing tiny ice nuclei into certain type of subfreezing clouds. It is also referred to as man-made precipitation or artificial rainmaking. It had been seen that it increases rainfall rate by approximately 10% to 30% per year. Also, it costs much less than the desalination process. Now comes how cloud seeding was begun. In the late 1940s, Langmuir and his colleagues at the General Electric Research Laboratory discovered that dry ice, when dropped into a supercooled cloud deck from an airplane, caused a rapid conversion of water to ice, leading quickly to the production of snowflakes and dissipation of cloud in the region. Soon they discovered that silver iodide had same nucleating property. Another method for stimulating the precipitation has been found by injecting salt particle near the base of cloud to provide center for droplet formation. After these discoveries, many experiments have been carried out all over the world. Today, different countries around the globe are undertaking cloud seeding, including America, Russia, China, South Africa, Australia, Canada, Israel, Jordan, UAE, Argentina, Thailand, etc. Then comes Indian history of cloud seeding. In the year 1951, Tata firm did cloud seeding over Western Ghat using ground-based silver iodide generators. In the year 1957 to 1966, National Physical Laboratory conducted experiment using ground-based generator in North India. In the year 1973 to 1974, year 1976 and year 1979 to 1986, IITM experiment with cloud seeding shows 20% increase in the rainfall. In the year 1983, year 1984 to 87, year 1993 to 94, Tamil Nadu government carried out cloud seeding. In the year 1990 to 2000, witnesses many advances in airborne instrumentation radars, flares, and softwares. They got imported to India in new millennium. In the year 2003, Karnataka government has initiated cloud seeding with modern gadgets like radars and aircrafts. Maharashtra government followed a month later. In the year 2003 to 2009, Andhra Pradesh government has conducted cloud seeding operation, perhaps the longest and the biggest program in Southeast Asia. Apart from this, many states witnesses cloud seeding operation in different times. Before moving further, we should know shortly how clouds are formed. The liquid water present on Earth's surface gets heated up by sun and causes evaporation. The water vapor formed rises up, it condenses around the dust or small particle floating in the atmosphere. Then these water particles accumulate, leading to the formation of cloud. Later, these cloud droplets produce rainfall, snowfall, etc. So, as mentioned earlier, clouds are tiny droplets of water or crystal of ice which float in the air. Clouds are made up of tiny water droplets or ice crystals that form when water vapor in the atmosphere cools and condenses around a tiny particle of dust or salt floating in the atmosphere. Without these particles, known as condensation on ice nuclei, raindrop or snowflakes cannot form and precipitation will not occur. A large accumulation of such droplet or ice crystal is a cloud. Now comes the type of cloud seeding. Cloud seeding is divided into three types: static cloud seeding, dynamic cloud seeding, and hygroscopic cloud seeding. The first type of cloud seeding is static cloud seeding. It involves spreading a chemical like silver iodide into clouds. The silver iodide provides a crystal around which moisture can condense. The moisture is already present in the cloud, but silver iodide essentially make a rain cloud more effective at dispersing their water. The static cloud seeding technique is one of the commonly used method. The second type of cloud seeding is hygroscopic cloud seeding. In this method, scientists spread hygroscopic salt onto the rain clouds. A hygroscopic salt is any type of salt that can absorb moisture from the atmosphere. It disperses salt through flares or explosive in the lower portion of the clouds. The salts grow in size as water joins with them. Hygroscopic cloud seeding hold much promise but require further research. The last type of cloud seeding is dynamic cloud seeding. It aims to boost vertical air currents which encourages more water to pass through the clouds, translating into more rains. But up to the 100 times more ice crystals are used in dynamic cloud seeding than in static method. The process is considered more complex than static cloud seeding because it depends on a sequence of events working properly. An unexpected outcome in one state could ruin the entire process, making the technique less dependable than static cloud seeding. Then comes the application. First is agriculture. It creates rain, provide relief to drought-stricken area. For example, Project Vrakshadhari in Karnataka in 2017. Second is power generation. Cloud seeding experiments have shown to augmented production of hydroelectric during the last 40 years. Third is water pollution control. Cloud seeding can help to maintain minimum summer flow of the river and dilute the impact of treated wastewater discharge from the municipalities and industries. Fourth is tackle air pollution. Cloud seeding can potentially be used to settle down toxic air pollutant through rain. For example, recently Central Pollution Control Board along with other researchers fueled the use of cloud seeding to tackle Delhi's air pollution. Apart from this, cloud seeding have many different applications as well. Now, pros of cloud seeding. It creates rain, providing relief to drought-stricken area. It makes a place more hospitable. It would allow for economic growth. It can reduce crop damage. It has the potential to help regulate the weather. Now, cons of cloud seeding. It is costly process as the procedures associated with this process are equally costly. It uses chemicals that might be harmful, but the impact is not severe. It can lead to abnormal or unpredictable weather pattern and flooding. It is yet to be fully proven as cost efficient and effective. Now we refer Karnataka cloud seeding as the case study. Karnataka state in India is highly prone to drought conditions. Most of the Karnataka is in the rain shadow region due to being in the leeward side of Western Ghats mountain range. This leads to large amount of clouding over Karnataka with potential or subcritical potential for rainfall. The monsoon rainfall in 2017 was deficient for the entire state until mid-August, and this provided a suitable occasion for taking up cloud seeding operations. Toward mitigating this adverse impact, the government undertook a project on cloud seeding using modern techniques. The infrastructure for the project consisted of radars at three locations: Bengaluru, Gadag, and Sorapur to monitor clouds over the entire state. The observations were supported by radio sonde equipment at Gadag, Bengaluru, and Solapur, which is closer to Sorapur. The early instance satellite data provide cloud cover, cloud top temperature, cloud motion vector, and potential water content. The rainfall monitor over the state was carried out using a calibrated dense network of rain gauge of 6,000 stations. The qualitative result indicate positive impact of cloud seeding and a viable alternative to recurrent drought hit areas. At last, we can conclude that cloud seeding is a most effective even though it is found not to be foolproof. Government and people should being adopt and follow different strategies for water source management before using cloud seeding. These include rainwater harvesting, artificial recharge of aquifers, conjunct use of surface and groundwater. The chances for achieving high rate of progress in agriculture sector and industrial growth is connected directly with the availability of water resource of a nation. So, cloud seeding become the necessary to tackle this critical situation. These are the references. Thank you.